Okay, so we're working through November 2014 Foundation Paper 2, and we're into the bonus questions. Basically, if we've got everything right so far, we're already worthy of a grade C, but let's see how straightforward the rest of these questions are as well. So first up, a dreaded utility bills question that students really don't like these. So Mrs. Owen received an electricity bill from Gower Electricity Company. The bill, with some of the entries missing, is shown below. Use the information given on the bill to complete all of the missing entries and calculate the total amount Mrs. Owen has to pay. Right, so her meter reading, so this ticks on every time a unit of electricity has been used. So it's used to calculate how many units have been used over the period between July 14 and September 14. So if we take those away, again I'll write down the full method down here, then we're going to have, this is what it is when it was red, that's what it was last time. So you do that subtraction, 2878, take away 1514. So she has used 1,364 units. I can put that in there. Price of each unit in pence. Now this is where most students muck up. Alright, because what happens is that they don't read that properly. That there, for example, is in pounds. That there is in pence. Now, when we were dealing with money in our pocket, we never had 0.3 pence. But with things like fuel, electricity, so on, they do charge decimal parts of pence. What I think you should do, or what I suggest you do, is you always work in pounds. So if that was 13 pence, written in pounds, hopefully you'd be happy to say, oh yeah, that's 0.13. Well, that is just 0.133. So cost per unit in pounds is 0.13 would be 13 pence, 133. Okay, so she's used that many units and each unit is costing her that much. So the cost of her units will be that many, each costing that much. And because now I'm working in pounds, my answer here is going to be in pounds. So that's going to be £181, and rounding that up because we're talking about money, 41. So that's how much the units used are going to be. She's then going to pay 5% VAT. So VAT, 5%, turn 5% into pounds, into decimal, would be 0.05 times that. So you could either do that, or you've got a percent button on your calculator. Okay, so if you just want to work out what 5% of that is, you would do times 5, and then to get that percent, shift and that, and you can see there, so it's times 5% equals £9.07. Two decimal places, 907. Next number is a 0, so it's just 907. So the VAT at 5% is going to be £9.07. Total charge, including VAT, so I'm going to add those two together now. So total Inc. VAT will be 181.41 plus 907 190.48. So that's what will go there. Now, she already owes, from her previous bill, she still owes the company £21.15. So the amount she's going to pay is that what's costing her from this bill plus what's carried over there. So the amount to pay would be the 190.48 plus £21.15. So she's going to pay £211.63. Now, sometimes in other questions that have come up, there's credit there from the previous bill. If she's paying by direct debit, you'll pay more in the summer than you need to, than you use, and then it's credited to what you would use in the winter when you're using more. So if that was a credit, then you'd have subtracted that from the 190, not added on. Okay, so the marks for that question, you'd have 1 mark for the 1364. You'd have 1 mark for the 181.41, 1 mark for the £9.07, 1 mark for the 190.48, and 1 mark for your final answer. So if you can practice those, go onto the topic papers on the Jones and Son website and look for utility bills and print a pile of those off, because if you can get into the habit of that, and that's the most important bit, is changing everything into pounds, then those questions always carry a lot of marks. Number 14. In an experiment, values of x and y are recorded to look for a possible relationship. The table below shows the results. Draw a scatter diagram to show the results. So with any graph where they're giving you an axis, the first thing to do is to make sure you're happy what each little square is worth. Now this is an easy one because it's the same scale on both, and you're going from 0 to 10 in 10 jumps, so each little square is 1. So it's a straightforward one to do. And we plot these pairs, so we go across 20 and up 16. And we put a cross. And make sure that you use a sort of sharp pencil and make the cross clear. 36.32 is there. 44.40 is there. 22.20 is there. And it's often worth, as you're going, making a little mark to know that those are the ones you've plotted in case for some reason you get distracted. So I'm on 38.34. So 35, 36, 37, 38 is there. 40.32 is there. 48.44 is there, and 8.6 is there. So got that plotted, and then we're on to, we need to see two things at once here now. The mean of the x values is 32. Calculate the mean of the y values and then draw a line of best fit on your diagram. So sometimes when drawing scatter graphs, they'll be happy for you to draw a line by eye, which means you just be looking for the general shape of the line and of the points and drawing a line like that. Sometimes they ask you to draw the mean point. So they've done the x values for you. So the y values, we need to add those up. So total y. So if we add up our y values, we've got 16 plus 32 plus 40 plus 20 plus 34 plus 32 plus 44 plus 6 is 224. So the mean y value, find the mean, you get the total, and then you divide by the number of data items that you've got. So 1, 2, 3, 4, 5, 6, 7, 8. 224 divided by 8, which is 28. Now, what you have to do when you've given you the mean point is you plot the mean point on your scatter graph. So we're going to go across to 32 and up to 28. So 32, 28. And try and make that point look different to the first ones you plotted. What type, and then draw a line of best fit on your scatter diagram. So now we need to make sure that our line goes through the mean. So you want it to go through or in the same slope as most of your points and through the mean. So I'm going there. And you don't take it through 0, 0 because it's not always that type of relationship. So you just take your line just beyond the two extreme points that you've plotted. What type of correlation does your scatter diagram show? Well, if as one value increases, so does the other. That's a positive correlation. Using your line of best fit, find an approximate value of y when x is 25. So this is something that is worth you drawing on your graph. So when x is 25, what you're doing now, or what I'm doing, is showing the examiner that I know how to use my graph. So I'm going to go like that. So I'm estimating that the y value will be 21. So marks for that question. 2 marks for plotting the points. Two marks for calculating the mean, and 2 marks for plotting the mean and getting the line through it. 1 mark for positive, 1 mark for an answer between 21 and 22. Number 15. The length and width of a rectangular television screens are often in the ratio of 4 to 3. Calculate the length of the shorter side of such a television screen when the longer side is 36 inches long. Well, the longer side is going to be the one with the highest number. So what we've got to do here is to make sure for a ratio that whatever that side has been multiplied by, that one has to be multiplied by the same thing. So in order to go from 4 to 36, you've got to multiply by 12. 4 12s are 36, which means to keep the ratio the same, you have to multiply this side by 12 as well. Hang on, 4 12s aren't 36. 9 4s are 36, so it's been times by 9. Excuse me. So 9 times 3 is 27. So we're looking at 27 inches. The size of a television screen, given in inches, is the length of the diagonal as shown in the diagram below. Calculate the screen size of the television described in part A. So in part A, I know that this side is 36 and I know that this side is 27. And what I'm looking at there is a right-angled triangle where I am trying to find the hypotenuse. So you're going to be using Pythagoras. There we are, telling the examiner I've spotted that. Now, when you're using Pythagoras, You square the information that you're given. So 36 squared is 1296. 27 squared is 729. So as soon as you see, oh, right angle triangle, I know two sides. It's not trig if you come from the higher tier. We don't do trig in foundation, it's only Pythagoras. So you square the sides you're given. Then you have to decide, are you going to add those together or take them away? If you're trying to find the longest side, you're going to add them because you need to make it bigger. If you're trying to find a shorter side, you take them away because you want to make the numbers smaller. Here, the hypotenuse is the diagonal, is always the longest side. The right angle always points to the longest side. So I need to add those together. So I add those together. So 1296 plus 729 is 2025. So that's telling me that the square on that side is 2025. Now I've got to do the opposite of squaring to work out what I'm trying to find. And the opposite of squaring is square rooting. So I'm going to square root my answer, which you can't see, it's 45. So what we're talking about there is a 45-inch television screen. So with Pythag on a foundation tier, once you've spotted it, square both numbers you're given, make your decision, am I trying to find the longest side, in which case I'm going to add them, or a shorter side, in which case I'm going to take them away, and then I need to square root my answer to get it back into the same form it was given. Excuse me. Okay, so marks for that. 1 mark for spotting the times 9, not times 12. 1 mark for your answer. And then for this one, 1 mark for adding your squares. 1 mark for getting the 2025. And 1 mark for square rooting to get 45 inches. So total for that page is 4, 6, 11. Okay, question 16. The diagram shows 4 identical large square tiles and 6 identical small square tiles. So I know that each of those from there to there, there to there, there to there are the same length. And similarly for the small one, that distance is the same as that distance. Find the length of one of the large square tiles. You must show all your work in. Right, so I can see from here that 2 big and a small add up to 26. And in this direction, well, that's 2 big and a small as well. Sticking an extra one of those small ones on it makes 30. So the small one must be 4, because the distance from there to there must be 26. So that distance must be 4. So small square has side 4. Okay, I've shown on my diagram how that is, so that's showing my working. So the length of one of the large squares, so that there must be 4, which means 2 large squares have side. So now I'm going to do 26 take away 4, which is 22 centimeters. So 1 large square will be 22 divided by 2, which is 11 centimeters. So 2 large and 1 small is 26. 2 large, 1 small is 26. So that extra one to make 30 must be 4. which means that must be 4, which means that and that together must be 22, which means each of them must be 11. And the marks for that: 1 mark for the small square, and then 1 mark each for taking it away and dividing by 2. Question 17. Okay, so what we've got there is a polygon, and each of these are an exterior angle of a polygon. So the first thing that you have to do in order to answer this question is know that the exterior angles of a polygon, any polygon, add up to 360 degrees. So the sum of all those angles is 360. Once you know that, then we can create an equation. We've got 3x plus 2x plus 38 plus 1x plus 34 are those angles, and that must all add up to 360. So we formed an equation. Now we can tidy that equation up because we've got 3x, 5x, 6x, and here we got 38 and 34, which is 72, must equal 360. And that's a fairly, at this level, a fairly straightforward equation now to solve. We're going to get the 6x on its own first of all, so we have to get rid of plus 72. We do that by taking 72 away. If we take 72 off that side, we have to take 72 off the other side as well. So 360 take away 72, 288. So now we want to get the x on its own. We have to get rid of the 6. The 6 and the x are joined by a times. So I'm going to do the opposite of timesing 6, which is dividing by 6, which in algebra we write like that. So we do 288 divided by 6, 48 degrees. Okay, so 1 mark for making them equal 360, 1 mark for forming the equation, 1 mark for one mark for trying to add them, 1 mark for the 360, 1 mark for putting them together in an equation, and then 1 mark for working out the equation. So 7 marks for that page in total. 2 more questions to go. Right, when you're factorizing, you are looking to take something out of those 2 terms and bracket them off. So you're looking for numbers or letters that divide into both. Well, 6 and 8, 2 go into. So you would put 2 outside the bracket, and then you'd say, okay, 2 divided into 6 goes 3. So 2 divided into 6x will be 3x. 2 into 8 goes 4, and it's a minus. So that's the factorizing process, and then you can check you're right just by multiplying it back out. 2 times 3x is 6x, 2 times negative 4 is negative 8. The nth term of a sequence is 3n squared take away 25. Evaluate the 40th term. So instead of n, we're going to replace it with 40. The 3 and the n will be joined by a times. So it'll be 3 times 40 squared take away 25. So 40 squared is 1600. Sorry, off the page. So that's going to be 3 times 1600 take away 25, which is 4800 take away 25, 4775. Write down the nth term of the following sequence. So look to see if they are rising by the same value. 19 take away 7 is 12. 19 and 31 is 12. So they're going up in 12s. So it's a 12n rule. Okay, so whatever is going up in, if it's constant, that's the n rule it is. So it's a 12n rule, but the first number isn't 12, so we have to do something to it to turn it into 7, which is to take 5 off. So first of all, you look to see what the differences are. That's the n rule. And then what are you going to do to shift the number that it is to the starting number that you've got? Alright, so 1 mark for that, 1 mark for correctly substituting in, and 1 mark for getting 4775. And for this one, you get 1 mark for the 12n and 1 mark for the adjustment to take away 5. The final question. A solution to the equation x cubed take x take 10 equals 0 lies between 2 and 3. Use a trial and improvement method to find this solution correct to 1 decimal place. Okay, so there are 2 different stages to this. First of all, we're searching for 2 consecutive 1 decimal place numbers. And the best place to start is halfway, because it's going to eliminate half the possibilities. So we're going to try x equals 2.5. The way that I teach this is I say that the x is a bracket. If you explode the x, so if you explode the x, bang, then it becomes a pair of brackets. So wherever you see an x, you explode it and you get a pair of brackets which we're going to put that number into. So explode, take away 10. And we want to evaluate that. Now we want to work out what that is going to do, what that comes to. So on your calculator, you have got an x cubed button. So we're going to type it in exactly as we see it. Explode the x, 2.5, close bracket, cubed. Take away, explode the x, 2.5, take away 10. So that equals 3.125. Now we're searching for the value of 0, so that's too big. So there's no point us trying 2.6 or 2.7. We know they're just going to get bigger. So our answer is somewhere between 2 and 2.5. So the next ones to try would be 2.2 or 2.3. I'll try 2.3. Same again now, we're exploding and seeing what we get. So bracket 2.3 cubed, take away 2.3, take away 10. Okay, so this one is negative. So we're looking for 0, that's too small. So now there's no point us looking at 2.2 because it's going to be too small. So we know our answer is between 2.3 and 2.5. We're not consecutive yet. There's another number between there to 1 decimal place. So we're going to try that one. Let's see what that is. 2.4 cubed, take away 2.4, take away 10. So that's too big. So my answer is somewhere between 2.3 and 2.4. So I've got it between 2 consecutives. So now I'm going to write X is either 2.3 or 2.4 to one decimal place. So to decide, I go halfway between the two. So I say I'm going to test this now with X equals, and halfway between 2.3 and 2.4. If I said what's halfway between £2.30 and £2.40, I'm sure you tell me £2.35. And we see what this value is. And then if this comes out to be too big, then it means everything bigger than it is too big, so 2.3 is my answer. If it comes out to be too small, everything smaller than it is too small, so 2.4 is my answer. So let's see which it is. 2.35 cubed take away 2.35 take away 10. It's positive 0.627 blah 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 blah, which is too big. If that's too big, then you say so X equals 2.3. If it was too small, X would be 2.4. You have to do that final bit to get your 4 marks. So you're going to get 1 mark for any substituting in and working it out. You're going to get 1 mark for getting it down to consecutive, and then 1 mark for going to that final test and working out your final answer. So the total for the final page is 9 marks. And that's it. That's all the questions on that November 2014 paper 2.